So in this question, we have a company selling washing machines, and the price per washing machine depends on how many washing machines they sell. And it's 440 minus 0.3x, where x is the number of washing machines sold. Now, if we think of this function and graphing it, it would be a straight line going down. It's a linear function, and the more washing machines they sell, the cheaper the price of the washing machines. If they sell a lot of washing machines, that means they can sell it for cheaper, and it's described by this linear function for the price. So the first thing is, well, what's the revenue, the money they're going to take in from selling washing machines? What's it going to be if we sell X washing machines and the price per washing machine is 440 minus 0.3x? Well, it's obviously going to be the number of washing machines they sell, so number of washing machines multiplied by the price per washing machine. So the price per machine. So using what we've been given in the question, the revenue is going to be the number of washing machines, which is X, multiplied by the price per washing machine, which is 440 minus 0.3x. And if we multiply this out just to tidy it up, we have 440x minus 0.3x squared. So that's part one of the question. Part two of the question asks us now to make a profit function, so p of x, and they tell us that the profit is the revenue minus the costs. So profit is equal to the revenue, the amount of sales you're going to have from selling the washing machines, minus the cost, which is obviously the cost for making the washing machines. And that function has been given to us here. It's 6,000 plus 0.5x squared. And if you think about this function, if you consider x equals 0, where we make no washing machines, there's still going to be a cost of 6,000 euros, and that's going to cover things like light and heat and overheads and renting premises, etc. And then for every washing machine you make, you have to square that number and then times it by 0.5, and so there's going to be an increasing cost depending on how many washing machines you make. So this is our profit function. So what we're going to do is we're going to sub in the r of x, the revenue function we found earlier, 440 x minus 0.3x squared. We're going to subtract the cost function, which is 6,000 plus 0.5x squared. Just make sure to put that cost function in a bracket, because you want to subtract both pieces of that function. If we don't have a bracket, we'll end up just subtracting the 6,000, and we won't actually subtract the 0.5x squared. Tidying this up, I'm just going to remove the brackets. So this is 440x minus 0.3x squared minus 6,000, and then minus 0.5x squared. And then just tidying up the function, combining like terms, we have minus 0.3x squared minus 0.5x squared, which is minus 0.8x squared, and then plus the 440x, and then minus the 6,000. And so we have this quadratic function that represents the profits. We're not asked to draw a graph, but we can see it's a minus x squared function, so the profits would initially increase, and then after a time they would come back down again, because it's an n-shaped curve if we were to draw it. Okay, so we're just going to leave this profit function here, and we're just going to erase the rest just to give us some space to write down the next part of the question. Lots to erase. So part C of the question then tells us, still erasing, part 3 of the question asks us how many machines must be produced to maximize the profit. So in calculus, so we're doing a functions and graphs question, there's some calculus involved. In calculus or differentiation, to maximize or minimize a function, what we do is we differentiate that function and then we let it equal to 0. And again, if you're thinking about that on a graph, if we differentiate a function, we find the slope, and the maximum point on an n-shaped curve would have a slope of 0. If you were to draw a tangent at that particular point where the maximum occurs, the slope would be 0. So we differentiate this function, let it equal to 0, and we're going to find out what the x value is for that. So let's write down p of x again, which is minus 0.8x squared plus 440x minus 6,000. We're going to differentiate the function, so we'll say dp dx. We're differentiating the profit function in relation to x, with relation to x, the number of units sold. So we bring the power down the front, 2 comes down and multiplies by minus 0.8, so that's minus 1.6x. And plus 440x becomes 440, and then constants become 0 when you differentiate them. So this is our rate of change, or our slope, let's say. So we let this equal 0 to find the max, and we get minus 1.6x equals minus 440. We subtract a 440 from both sides. Divide both sides by minus 1.6, and we get that x is equal to 275. So we'll maximize our profit. So maximize our profit when x is equal to 275. So when we sell 275 units of the washing machine. The final question then, part 4, asks us, well, what is that maximum profit? So the part 3 was how many machines do we sell to make the maximum profit? That's going to be 275. But part 4 then asks us to actually go and find that maximum profit. So what we're going to do is we're going to stick the 275 into the profit function for x, so minus 0.8 times we're selling 275 units, and square that, plus 440 times 275 minus 6,000. We can throw all of this into our calculator and we'll see that the maximum profit is 54,500 euros. And that occurs again when we have sold 275 units.